Hello friends, welcome to this second tutorial of PSIM. In previous tutorial, we have gone through basic operation of PSIM software. We have also generated a simple circuit with two resistors in the series. If you have not watched previous video, you can see the previous video, link has been given in the description box. Today, we will try to see waveform of different type of sources available here. And after that, we will also try to generate simple diagram of Fullwave rectifier, and we will also observe the voltage across the load and voltage across the diode for each. So without wasting time, let's get started. Friends, here some of the sources are also predefined available. Here first source is DC voltage source. We can take a DC source here and we can check the voltage tendency across the DC source when we are connecting a resistor with it. Here I am taking a simple resistor. By clicking right click, we can rotate it clockwise direction. After the proper connection with this wire tool, we can make a closed path for the current flowing. I have connected this circuit. Now for the voltage checking, we can take this voltmeter and we need to connect it in the parallel manner. Again, I am taking a wire tool and connecting it parallel with a resistor. After that, for the run this circuit, we are supposed to provide ground. So it will be available from here only. We can take a ground and put ground over here. For that, we are also need one button, simulation control. It will provide us the basic information about that. Here I am not going to change the time step, but total time for the simulation, it will be 1 second in our case. After that, we need to just run it. So here we can say that our peak voltage and step signal we are getting. Here our peak voltage is 100 volt. If you want to change it, by just double click, we can change the amplitude of the voltage. Now if I suppose to check 50 volt, then I need to add 50 over here. So by clicking run button again, it will be changed to 50 volt. This is all about basic DC voltage. Now as we are aware about the sinusoidal voltage, I am taking a sinusoidal source here. Again I am taking another current source and another voltmeter for the checking the voltage across this resistor. By clicking this wire tool, I can make the connection very easily. Again we require one ground source. Now these are the parameters available for the sinusoidal. We will check it one by one. Peak voltage is 110. Here in our case, we will try to plot a diagram for 230 volt. While it is a given that 60 Hz frequency, but we will go through 50 Hz frequency. Phase angle will keep as it is 0. DC offset, we are not going to put any type of offset here, so it will be 0 as it is. Series resistance and series inductance, in our case it is not required. So if I wanted some information to be displayed here, I need to click the display button. So I am clicking on the 3 of them. So it will be displayed that 50 Hz frequency to 30 volt peak amplitude and V1 as our voltage source. Here make sure that I am not going to change the RMS voltage. Here peak voltage is 230 volt. Now this is our voltmeter. By double clicking that, we can also rename the voltmeter. Here I am changing it to PSIM. So for our easiness, it will be. Also I am clicking on the display, so PSIM will be available here only. Okay, by double clicking on the register, we can also change the value of register and name of register. Here I am also changing with PSIM. Now I need to run again this. So they will ask which voltage we need to see. Here I am taking a PSIM. So here we can see that our sine voltage is starting from 0. It also going to peak at 230 volt, and again we have set our frequency to 50 Hz. So our one cycle will be of 20 millisecond. Here we can see that in the 20 millisecond our one cycle will be completed. and after again 20 milliseconds second cycle will be started and finished at 40 milliseconds. So this is all about our sine wave generator. In our case, third wave is triangular. So different type of functions can be run in the triangular and square waveform. We'll see one by one. Here I am taking one triangular source with single resistor and voltmeter parallel to that. Now as we all are aware about the connection, it is very simple, so I am connecting it in a rapid manner. We need to provide one ground button here. After that we can change the parameters. Here display is V triangular, we are not going to change. Peak voltage, here peak to peak voltage they are asking. We will set peak to peak voltage to 8 volt. Frequency is 1000, this is by default. Here I am going to change 50 Hz and duty cycle is 50%. So in the 50% time, our half of the triangular wave will come in the rise manner and another 50 cycle it will go to negative manner. Here offset is also given -1 volt. I am not going to change it. Now let's change to 0. I am not putting any type of offset over here. Okay, we need to see this and also want to be displayed in our display. Okay, now this is voltmeter, we will change it. We want that VTR1, so it will give me triangular waveform. Okay, another value I am keeping as it is. Now again I am running this program, so they will ask which waveform I want to see, but here I am watching V triangular. Yes, we got our waveform. It can be seen that our waveform is starting from 0. It touches its peak at 10 millisecond, means 50% duty cycle. It touched to 8 and again it's going downwards to 0 after 10 milliseconds. So one cycle will be completed in 20 milliseconds as we have set our frequency to 50 Hz. So this is all about our triangular wave. Now I'm doing some changes in the triangular wave. Here our duty cycle is 50%. If I set my duty cycle to 75%, so first 75% of time it will rise and after remaining time, that means 25%, it will goes down. So again I am running this program and we will get some another result and it will try to look. Here our whole cycle will not change because we set the frequency as 50 Hz. So our one cycle will be completed in 20 milliseconds, but rise time and delay time is going to change. Okay, this was all about the triangular waveform. Now another in our case is square waveform. Again I am set the square waveform here. I am taking a one resistor here and parallel with voltmeter. For the simple connection I am connecting with a simple wire. Ground terminals is available here. Different type of parameters. Here we can see that square wave peak voltage I am also going to change with 8. Frequency I will keep it as a 50 Hz. Duty cycle for this our case we will set is 0.5, means 50% duty cycle. Now this will not be VP4, but in our case it will measure the square wave, so I am changing to SQR. I need to be displayed here. Then again I need to run this program. After run this simulation they will ask which waveform I want to see, so I am selecting square. Yes, I am getting the square waveform. Here we can see that our cycle is starting from 8 peak to 0, then this is our 10 millisecond time and again it completed here. So if I want to start my waveform from 0, then I need to change this parameter and it should be 0. Yes, we'll get our waveform like this. We can see that first 10 millisecond our signal will be high, and another 10 millisecond our signal will be 0. So our one cycle is going to complete in 20 millisecond. After 20 millisecond the same cycle will be repeated. Here we can also change the duty cycle. Here for our easiness we kept on 0.5 means 50%, but if I am going to change with 0.1 means first 10% it will be high and after 90% it will be low. So the waveform for that is look like this. Yes, 10% at time it turns on and another 90% at time it will be low means 0 volt. But the case is I'm again changing it to 0.5. I'm not gonna change it here also. I'm going to change it 0.5. Now if I want all the graphs on the single graph paper, then what I supposed to do with it is just I am selecting VP1. So I am going to waveform like this. Now I will add another screen. Now in the screen I will see sinusoidal graph. Here I got 2 graph. Another I will try to add the screen. In this wave I will see square wave graph, and the last one will be on this V triangular. Yes, we can see that we have set all the frequency to 50 Hz. Sorry. So our sinusoidal signal will start and come to the back to its original position after 20 millisecond. Same for square wave. Square wave signal has been start from 8 volt means peak voltage. After the 10 millisecond it will return to the 0, and another 10 millisecond it will come back to its original position. So here also we can observe that frequency is 50 Hz, and in the triangular wave also we can see that it is starting from 0 and touch to its peak to 8 volt after 10 millisecond, and after another 10 millisecond it also come to back to its original position. It's 20 millisecond. So it is all about our different type of wave generator. It can be used in the get signal of semi-controlled and fully controlled switches like thyristor, MOSFET and IGBTs. Here today we'll not going to dip on that, but we'll try to see uncontrolled rectifier, means full wave uncontrolled rectifier. Here for the uncontrolled rectifier our switch will be diode. So we are very much aware about the circuit diagram. I am selecting the switch. For that I need to go on the power and switches. I will get diode directly. By right clicking it I can change the direction. For the connection, this is our D1, this will be our D2, this will be our D3 and D4. Okay, for our easiness I am making some space in between that. I am taking a wire and making the connection properly. This is unwanted part, we don't require it, so I am making it deleted. Again need to connect these 2 points and the 2 send. Here I am changing AC to DC. So we are selecting AC wave means sinusoidal wave. This is our sinusoidal source. So connection is very easy. We need to give it at our anode of the first leg of this diode and another anode to second leg of this diode. Now we need to change the parameter of this AC. We are going to put it as a 25 volt and also changing frequency to 50 Hz. I need to be displayed here V sign for rectifier, V rectifier input, V input. For our easiness it will be V input. Now I am going to put load, and our load will be resistive only. Yes. So our AC wave will start from here and we'll get our DC output across the resistor. There might be some problem in the connection. I'm watching this unwanted part. I'm making it delete and again connecting it. Yes, now it's perfect. Okay, for the observing this voltage, we are supposed to provide voltmeter over here. Yes, I'm connecting a voltmeter across our resistor, and this connection is like this. Here we can see that our first cycle will start to go like this. From diode 1 it will go through load, and from diode 2 it will close the path. So this will be our diode number 1. So for our easiness, I am giving the diode number 1 as a display, and this will be our diode number 2. Yes. Okay, now in our negative cycle, this scene is like this. For the negative cycle, this is our anode, and current will also only pass through anode to cathode. So this will be our diode number 3. I am changing it and make it visible for us. Current will flow from this resistor and it will enter to this diode and will be back to our source. So this will be our diode number 4. Yes. Now the circuit is completed. Okay, we need to provide some ground path here. So I am connecting a ground over here. Okay, and I'm also going to change this output as a VDC. As we are getting a DC output here, we are changing it to VDC. Yes. Now I'm going to run this. First of all, we will see the input. So where is our input? I'm not getting it. Let me check this. Yes. I don't know why I'm not getting V input over here, but let's check our output whether it is coming. Yes, we got our output as we have set our frequency to 20. So one cycle has been completed in 20. Here we'll have our input signal. Our input signal is like this. So our rectifier will work. Our AC signal will be converted into the DC signal. Here we can see that in the first cycle we are getting a positive cycle. So it is as it is in our DC waveform. While for the second cycle, our diode D2 and D4 will try to convert this negative cycle to positive one. So our positive cycle is going to change to another positive cycle. Yes, it can be observed over here, but now we'll change some variation over here, and we are changing our load resistive to resistive plus inductive load. So I am making disconnecting it. I am also making disconnecting it, taking one inductor over here and making connection. It is connected properly. Again I need to run this program. There will be no changes in our DC as we are using a fully uncontrolled rectifier. So we are not giving any type of trigger pulse for controlling the switch. So as we are getting the same output, our first cycle is going to complete in 20 milliseconds and half cycle is going to complete in 10 milliseconds. So this is all about the simple full bridge rectifier. In another video, we will try to draw and analyze the full bridge rectifier for the 3-phase source, and also do some uncontrolled, semi-controlled and fully controlled rectifier. Okay guys, thank you very much for this video.